Okay, welcome back. Today we're going to be covering the observations and some of the explanations associated with the Roman engineering slideshow. Okay, so like I said, we've got a large number of slides to go over, and I'm going to kind of do these in the groups. I hope you spent a fair bit of time observing each one of the slides, but I'm going to try and cover the essentials of the roads, the Segovia structure, so on and so forth as we go through that. So let's get started with that. Again, here we go. We're going to do the physical, the Roman engineering observations. Okay, so first one was the Roman roads. Now, I'll quickly cycle through these just so you can take a look at all of them again. But the main thing to take away from the Roman roads is that these things, they're just pretty simple cobblestone roads, but they've lasted over 1,000 years. A lot of times they've been, like in this case, they've been turned into kind of tourist attractions. This one, I believe, was in the process of being excavated. You can see that eventually they do sort of get covered in dirt. But the road more or less survives underneath the way a simple path wouldn't. Now, this one I find particularly interesting. I believe this was the main road that led to Rome. It was called the Appian Way. But what you can see here is you can see little grooves worn in the cobblestones themselves, and those are grooves from wagons. So one of the main things to remember about roads is that it enables trade. And this was one of the things that the Romans were able to do. They were able to trade in a lot of different places. And one of the things that made that possible was the roads. They were not particularly good sailors. Most trading cultures have been sea-based. It's a lot easier to sail over the sea using the wind, or even maybe just oars, than it is to go by land. But the Romans were able to do this with their roads. They were one of the few cultures that did this very, very successfully. Another thing that the roads enabled the Romans to do is basically you can walk on roads carrying heavier things. And this enables, if your military is largely consists of just soldiers walking around, this enables, or maybe even horses, this enables you to not only transport them, but also transport their supplies much more quickly within the Roman Empire. So one of the things that the legions were famous for, the Roman legions, was their ability to relocate quickly. And the roads were a big part of how they helped them do that. Now, it was actually the legionnaires who built most of the roads. So most of the Roman soldiers wouldn't spend their time fighting. Let me put it this way. An average Roman soldier, most of his time as a soldier was spent building roads or other structures, not necessarily fighting. Though, like I say, the roads as a military technology did enable the Romans to be quite successful militarily as well. So, yeah, those were the roads. So we're going to move on to the Segovia structure now. Now, basically what this looks like, it looks like a really tall, narrow bridge, but it's just a bridge that's kind of going through this city. From this structure, it's not apparent if it's bridging to anywhere. Now, it's got these long columns, and these columns are basically of stacked stone. And this is one of we've seen this a little bit, but it's a motif that comes up over and over again, and it is this shape. And that's somewhat similar to the corbel, but we'll look at this a little bit more closely. But it makes a semicircle as opposed to sort of a jagged triangle shape that the corbelled arch made. And this is either a semicircular arch or a Roman arch, one of the main things, and we'll see this over and over and over again. So that was one of the main forms that I was hoping you would pick up on as you went through this. So let's go to the next picture in the Segovia structure. And one of the things you can see here is, again, you can't really see where this thing is going. So it's not like a bridge where you have to span a chasm or a river or something. This thing just seems to be sitting out in the middle of the of the city. Now, I believe this one used to continue on. It no longer does, except for this section, which the city in Spain has preserved because it was so impressive. But they had a much, much larger, much grander purpose. But a lot of times we preserve these pieces of the technology going forward. So you can see, like I say, it's stacked stone. You can get a little better sense of what the stone is doing. So if we back up to here, if we look at the arch, as opposed to having them overhang, they're tilted. So they form this semicircular shape as they're tilted together. And it turns out, we'll look at this in a little bit more detail in a future lesson, but it turns out that this is quite a strong structure, one of the strongest structures that we've seen. So yeah. All right. We'll go to the third one, and here is actually much better. You can see the arch significantly better here. So you can see the stones of the arch kind of all joined together there. Now, one of the very impressive things about that is there's no kind of adhesive holding them together. They're just held in place by basically the weight of everything around them, their own weight and the weight of everything around them. We'll look more at how that works when we talk more about the Roman arch. But there's no sort of no mortar or anything sticking together there. Up here, on the other hand, we do actually see some mortar, and this is not just simple mortar. This was the new material I was hoping you would look at. What we have here is one of the first historical uses of concrete, and in this case, it's being used more as mortar. Like you can see, it's holding these stones together. But the function of this structure, it makes it very important that you can't just have the stones fit, sort of okay. You need to actually have it sealed and have like a perfect fit. And concrete and mortar were essential for that. So this picture you saw, this is what the top of the structure would look like. This is a different one. It's not the Segovia structure. I think this one is in Turkey, if I recall, but I don't remember. But this is what the top of it is. And it's not really a bridge. It's a little too narrow to be a bridge. Basically what we have is we have this sort of weirdly shaped, not weird, but just narrow channel at the top of these things that were surrounded by stone. And it turns out that this one is broken down, but there would have been a slab covering this thing, and it would have so it would have been it would have been covered as well. Now, I didn't show this next one, because I thought it would give it away, so this is a new slide. But this is what it would look like. And what this was actually called an aqueduct. That's what the Segovia structure is. And aqueducts were all over the Roman Empire. And basically, again, this thing would have been covered by slabs of either wood or rock, depending on where they were. But basically, what you have here is you have water flowing down this channel. So that's why you need the concrete, because you don't want the water to leak out. And the reason you have water flow down these channels is this was how Romans supplied their cities with water. This was a major limiting factor in how cities could grow, is if there was not enough fresh water, they could only get so big. Everyone needs water every day. And so what the Romans would do is they would basically build these artificial rivers called aqueducts to bring water from places where they had a bunch of extra water, to their cities. Now, one of the things we now understand, they apparently did not know about groundwater. In most places, you can just dig holes in the ground and you'll eventually get to water. And it's not perfectly clean, particularly once you start using it, but it's basically drinkable water. And this is how other cities got big, is they took advantage of groundwater. But the Romans didn't do this. They used these aqueducts. So here's a larger diagram of what it would be. So this one is not labeled in English, but it was the free version I found. Basically what you would have is you'd have a large water source over here. If you needed to, you might tunnel underneath a hill rather than, trying to get it to go over. But what you wouldn't want to do is you wouldn't want to let the water flow down in the valley because you never had a way out. So that is why the Romans would build these aqueduct structures so that the water could just take this gentle downward path into a tank near the city, and then the city could supply all the houses and buildings with water. Now, not every Roman house would have running water. Mostly this was for the noble houses and the more important buildings. But there would be public fountains that people could drink from and people could go get water from. So this was how the Romans did this. Now, we actually we do something similar in storing the water in water tanks, but one of the things we don't need to do anymore is we don't need to build these very impressive tall bridge-like structures for the aqueduct. We actually can use plumbing systems, and the Romans did eventually figure this out. Once they did, they stopped building these impressive structures, but they never tore them down because they're kind of cool. But you can actually use pipes instead of sealed pipes instead of open pipes, open channels. And you can actually go down and then back up if you do that. And we'll go over that a little bit later in this course how that works. But Romans didn't know that when they first started building this, so they made these very large bridge-like structures for their aqueducts. Now this is a more a proper bridge. This is the Alcantara Bridge. I believe this is also in Spain, actually. And this one we can actually see is designed to channel a river. And you have another instance of the arch here. Quite a long span of the bridge. Now, we saw this in the previous structure, the Segovia structure as well, but I did want to point out that what you end up having a lot of times with arches is you end up stacking them all in a row like this. So one arch next to another arch, next to another arch, next to another arch. This is actually the origin of the word arcade. I don't know how arcade became a spot where you played video games. Maybe no one watching this has ever been to an arcade, but they were still in fashion when I was a kid. And but so I don't know quite how that term evolved to mean that type of area, but this was the original meaning of the term arcade. So it's very similar to the term colonnade. Remember, that was a row of columns in a row. An arcade is a row of arches in a row, and very common to do with both bridges and aqueduct structures as well. Now, this one is this is a different angle, slightly older photo as well. The reason I wanted to see this one is with these two columns in particular, these two pillars for this bridge, they were made in the water. They were placed in the water. So this was something that the Romans eventually figured out. They figured out a way to make concrete that not only, like I said, could it act as similar to mortar, but it could hold things together and hold these pillars together as it set and hardened with inside water. So this was it was more than other cultures had figured out the sort of the basics where you could use mortar to fill in cracks and seal things off in stone structures. But the Romans are really starting to make structures that rely on this type of concrete that can be set. If we go look, there's a zoom in function. I don't know that I can zoom in anymore. I think the next picture does it though, so I will. There we go, it's zoomed out. Okay, so going on to the next picture, we can see, again, some of this it's a little difficult to know what's the original Roman, what's new, but you can definitely see sort of the mortar being used as concrete here to kind of hold these bricks together, make the structure a little bit stronger, a little bit more durable. And as I said, some of this has been repaired in the years since it was first built, but we do know the Romans did have this technology as well. Now, this is the second bridge I wanted to show you, and this is just going to be in sketches. Most of these were adapted from Julius Caesar's journals, which I believe you can still read. I think they've been they're I'm certain they're in English. But basically, this was a temporary military bridge that he used to cross the Rhine River. Now, he's most famous for crossing the Rubicon River because historically, once he crossed the Rubicon, he brought his army into Rome. And when he brought his army into Rome, that meant there was basically no turning back, and he had to, become the dictator or be executed by the Senate. So this is that phrase, crossing the Rubicon, that's actually where this comes from. Now, if you've ever heard that. Now, I actually think crossing the Rhine was more impressive engineering-wise. The Rubicon was kind of a little stream. His troops could just walk across it. The Rhine was quite a feat to cross. And he kind of wanted to go over and fight the barbarian tribes on the other side, but he didn't have a convenient way to cross this. He could have maybe built boats. That would not have been super convenient. That was probably how locals crossed the Rhine. It's got an unpredictable current, but it's not extremely rapid. But what he decided to do instead is build this wooden bridge. Get his military engineers to work and build this wooden bridge. Now, one of the things you're going to see, a little difficult to tell from this angle, but one of the things you're going to see is that he braced these initial these initial structures that ultimately held the bridge. He had them angled down into the riverbed, and the way he did this was quite ingenious. I'll show you the tool he used, but I'll see if you can figure out how he used the tool. But then he laid a cross beam across it. So this sort of two angled pieces with a cross beam across it. This turns out to be quite a sturdy structure, and we'll see this a little bit later. Hopefully you caught that in the roofs. This is not exactly the same thing, but the angled pillars with the horizontal crossbeam turns out to be quite strong. And you'll notice up here he had these sort of these little things to kind of protect it from the current, to kind of divert the current. And then he just basically laid lintels across it, treated each one of these things as a post, laid lintels across it, and then took other twigs and things across that, and then his army could march across it. So here's another angle of that. Whoops, went too far ahead. And you can again see the angled supports with the lintels across, and then sort of different lintels laid across like that. Now, getting the supports in was kind of the harder thing. Once he got the supports in, he managed to go pretty quickly. Turns out he built the entire bridge in about 10 days. Very impressive. This was the tool that this is a replica of the tool that was actually used to build the supports of the bridges. Now, like I said, I'm not going to tell you how this worked. There's a video you can watch. Rome Engineering and Empire tells you fairly. I linked this in the lesson, but tells you it shows you actually how these things worked. But kind of impressive. So before you watch that though, see if you can figure out how this tool would work to build those supports for the bridges. They're called piles, incidentally. That's the name of these long supports that are sticking into the ground. These things are called piles. I don't actually know why they're called piles, but that's what they're called. Okay, getting into one of the more famous structures in Roman architecture, the Colosseum, or the Flavian Amphitheater. I think is its technical name. Now, one of the important things to notice here is that you have sort of a combination. You can see, if you look closely there, you can see these are Ionic columns. You can see the pedestals right there. And you do have sort of a lintel there, but you've also combined it with that Roman semicircular arch. And you see these all along here. Now, going into the amphitheater, it's not just an arch. Like this one right here, like these ones down here, these are making long arch-shaped hallways. Now, we call these vaults. Remember, we called it a corbelled vault when it was in in Egyptian structures? Well, we just call it a vault when we're dealing with a Roman arch. We could call it like a Roman arch vault or something like that. But basically, it's you instead of stacking them side by side like you would with an arcade, you put them kind of next to one another so they form a long tunnel. That is how the vault works in the Colosseum. And there's a significantly whoops. Cannot seem to stop doing that. Okay. So this one, this is an example of the Colosseum interior. Now, the main thing to show here is that it's not just like there was flat ground inside this interior. You have all these long hallways, where, they would keep gladiators or other animals or possibly other things as well. There's a little bit of history as to why this is the case and how it actually relates to some of the plumbing. If you watch the video, you can actually see that, because this was actually built on a palace of another Roman, on the ruins of a palace of another Roman emperor, who was not entirely well liked, but you can kind of see there's a lot going on underneath this Colosseum, and it was used to they would have elevators that could bring people up from below it, and they would have trapdoors so these lions or tigers could spring out of them and attack people and surprise them. It was kind of gruesome, but quite an ingenious engineering design. The Roman people absolutely loved it. Another just angle of the Colosseum interior, just to see the different ways that they used arches and concrete and vaults. You can see that. And then I wanted to show an example of a longer vaulted tunnel. That was kind of the point. That basically you could make these tunnels significantly wider than was possible with the corbelled tunnels that we saw in the Egyptian structure. So this seems like a legitimate hallway. Now, in modern structures, a lot of times, we'll talk about this later, but we'll use strengtheners inside these structures, and basically the main strengthener we use is steel. We can make very sturdy structures using steel to reinforce it, and we'll talk about how that works. But as a reminder, these were not made with any steel. These are just concrete and stone. And the fact that they could make a tunnel this wide was kind of impressive, because there was no, the corbel wasn't capable of doing that. You might be able to do it with the triangular arch, but even with the triangular arch, there's not a whole lot of space there, because it's angling up. So, on the edges, you'd have to be really, really short to walk there. So you basically still have to walk down the middle. With the arch, with the Roman arch, you get to have some pretty spacious vaulted tunnels here. Okay, so this is an example of Trajan's Forum. Now, I just kind of wanted to show this as just as sort of an interesting building that the ancient Romans were able to construct. But there was one thing in particular I was hoping you would pick up on. And it's a little difficult to tell if it's actually part of the building or just part of the camera. But this entire structure right here, this thing, it's shaped like an arch. Okay, it's like a big giant arch, and turns out this is actually deliberate. The architect who designed this did this and made this design deliberate. So if you picked up on that, good job. Go ahead and watch the video for an explanation of why it's done that way. All right, the Pantheon. Now, hopefully you can pick up the Corinthian Columns. Like I said, these are Corinthian columns, but they are not fluted Corinthian columns. So hopefully you were able to see that. Now, the other thing is you have sort of a Greek style roof. So this first side of it is quite Greek in its orientation. But back here, the rotunda structure is where it becomes significantly more Roman. So that is actually what we're going to focus on. But first, let's look at this from another angle. Now, what you can see here is sort of the third variation on the arch. We had the basic arch, and then we had the arcade, that was the second variation. Then we had the vault, that was the third variation. You have a sort of fourth variation on the arch, which is how I got up to 5 structures, where you take the arch and you sort of spin it around in a circle. And that makes this room-shaped thing called a dome. So you can see the dome a bit better. Didn't have a lot of great pictures of the Pantheon from the air, but you can look up some of those. You can still see this. The structure is still standing. You can visit it if you go to Rome today, but you can see that dome inside it. Now, going into the sketch, you can definitely see the dome more clearly. I just wanted to just to give you a sense of how big this dome is. And this one in particular shows kind of what they were doing with the dome. And hopefully you picked up on this, but the material is significantly thicker at the base of the dome than it is near the top of the dome. So one of the reasons is, again, if there was steel reinforcing this, it would probably be fine. But with concrete, when it's this big, and you can see it's quite a large structure. You've got people are maybe this tall. So this structure is this tall right here. So this structure is quite large, and actually people are probably a little taller than that, but no big deal. So it's very heavy, and there's nothing supporting it. Like, there's no pillars inside the dome to keep the dome from falling. So one of the ways that they made it lighter is they made the material thinner as you got toward the center of the dome, toward the top of the dome. Now, you can't see it extremely well, but right here, this was another thing they did. One, to make it lighter, they took the entire, they kind of took the, instead of capping the dome with more stone, or more concrete in this case, they made just a hole in the top of the Pantheon dome, and you can see it here. And one of the things this does, not only does it save weight, but it provides this sort of very interesting light. The interior of the Pantheon is lit in a very interesting way throughout the day due to this annulus at the top of the dome. Another thing they did to save weight, you'll notice these structures are recessed. So instead of making it entirely very thick everywhere, they made these sort of divots in the concrete, and that's what this is made out of. It's all made out of concrete. But they made these sort of divots in the concrete so it wasn't quite as heavy. And this was the way they were able to make this very large, very impressive dome without steel. So you can see, you can just see how, you got some people down there at the bottom, and you can see that this is really just a huge, huge structure. And again, very impressive for not having steel. And you'll notice that the interior is it's kind of been redone with a bit more Christian symbolism, and this building did eventually become a Christian church. Was not originally constructed that way, but it did become a Christian church. You've got the fluted Corinthian columns here. Hopefully you picked up on that. You've got some triangular arches forming windows there going across. So a lot of combinations of forms we've already seen here. So it's the last of the Pantheon. Now, the last thing to do in the Vitruvius sketch. The main thing to see here is that what I wanted you to catch was that you had this cross piece, and it's kind of similar to the prop and lintel, except at the base here, it's a little difficult to see in this drawing, you don't have a prop. Instead, what they do is they connect the rafters, the slanted elements, directly to the cross piece. Now, you might be thinking that doesn't really make much of a difference. However, it kind of does, and I'll show you we can kind of compare that. But again, you've got the connection directly to the crosspiece versus the props that were used in the prop and lintel setup. Now, the Roman setup is called the roof truss. And we, again, this one was the prop and lintel. And prop and lintel. And the Roman roof truss is only a slight variation on it, but it's a very important variation because it makes the entire structure significantly stronger. And we'll go into a variation of this, but we use roof trusses in structures today. This is just sort of an example. This one has multiple cross pieces, but you'll notice that the cross piece is put directly into the slanted elements. Now, in this case, this roof truss is actually just providing structural support, which some roof trusses, and eventually when they're not used to make roofs, they can be used to provide structural support. They're just called trusses. But anytime you see this sort of diagonal bracing with horizontal bracing, it doesn't have that's going to be a truss. And a lot of times it does make the overall structure stronger. And think about why that is. You should be able to make some of these on your own just out of popsicle sticks. And think about why the roof truss is stronger than the prop and lintel. And I'll go over a demonstration video of that as well. But it turns out it is significantly stronger, and so strong that we continue to use it to this day. So here's sort of a roof truss diagram, so you can see it a little bit better. You would have the horizontal element, the diagonal element here, and then you can place rafters on in between two roof trusses so that the rafters are kind of just being held up. A lot of times you don't need this, but you will have a center post. This is actually called the king post. King post. Sometimes instead of having a single post, you'll have diagonal elements. If you only have the diagonal elements, they're called the queen posts, or they're called queen posts. If you have it with the king post, I don't know if they're still called queen posts or not, so I'll avoid writing that. But those things just tend to make the truss stronger. Now, the main difference is that you need to build the truss before, you need to have this entire truss built before you even start on the roof. So you can't just bring in the lintel and then start constructing it. You could. It turns out it's not very convenient. So you need to use the truss as an entire unit that you then go construct the roof out of. That wasn't necessarily needed with the prop and lintel system. So the prop and lintel was probably a little easier to build, but turns out not nearly as sturdy. Okay? So think about why that's the case. Go ahead and test that yourself if you're able. And then once you have done that and done all your questions, you can go watch my video on the roof truss, and I'll try to explain what's going on with it. Okay, so that is it for this set of observations. Thank you for tuning in with me, and I will see you next time.